the preserved early Archean record doesn't necessarily mean they didn't form. It could simply reflect the brutal reality of geological time and preservation bias. Think of it as trying to find delicate early manuscripts after a library burned down. The hardiest tomes might survive, but most are lost forever. In contrast, geochemical and isotopic signatures preserved in minerals like zircons or in the bulk composition of basalts can be much more resistant to later metamorphism and alteration, potentially providing a more robust record of past processes. If we prioritize the oldest constraints, the geochemical evidence showing constant subduction-like signatures back to Forga argues for the long-term operation of subduction. The tentative suggestion from the basalt data of a progressive increase in the average depth of mantle melting over time, inferred from TO2MGO and Na2O-MGO systematics, also fits better with a plate tectonic flux melting scenario modified by a cooling mantle, rather than a simple decompression melting model. In a flux melting setting, the depth of melting can be influenced by slab dehydration, which in turn is affected by mantle temperature and slab composition. While there's room for further research, this trend seems consistent with a predominance of flux melting, supporting the idea of ongoing subduction. To wrap this up, analyzing large geochemical datasets of continental basalts using robust statistical methods reveals a complex but interpretable story. While acknowledging the limitations of sampling